Thanks for having us today. Thanks for the interest in our system. Everybody, all the participants also. Vision 42 is an online company. So we try to take the data that has been created and take it and treat it in an online fashion. We try to do this because that gives us the most flexibility on having new technologies and new innovations. We try to incorporate all types of data that are necessary and are used within the monitoring field, of which is, of course, inclinometer data, as we see today. And I will show you what we do for that specifically today. But we try to be as vendor neutral as possible and incorporate IoT, incorporate all sensor manufacturers and a lot of instrument types. We've always done this with a number of pillars on the background. So people who use these types of systems tend to like having their data as fast as possible. So one of our core things that we look at is providing you with instant information. You can see it. It's one of the normal operations in the system. This should be something that's rather quick and easy. As said, we integrate just about any data format that you provide us, and we do this in an as seamless possible way, which means that we try to look at the metadata inside data files and use that to populate our system, so you have less configuration work. But that's not really why we're here. You have also some field engineers. It's a problem that hasn't arisen. But for example, if you're looking for boreholes, one of the features that we provide is that you can have some kind of an augmented reality view. If you've got your sensors located in the field, you can have this type of view, which could be useful should you have lost one of your boreholes in the field. Project managers tend to like a lot of data, and they tend to have some overview. So this gives us the view that our system can handle a lot of projects. So that's not really an issue. Of course, what we're here for is inclinometer data. This is our demo environment. Should our clients get this in a branded fashion, so it can be used as a portal for their analysts and their clients themselves, so they can grant access to everybody who wants it. On inclinometers, just to give you an overview, we created some kind of a project where we collected some inclinometer data. As you can see, this is the way the system works. We provide you with a map view. Yes, this is Hell's Gate still burning after all these years. One of the data formats we do is, in fact, DGSI. And as you can see, we show the inclinometer in the vertical fashion. We do the cumulative calculation as discussed by Giorgio, very thorough in explanation there. So I won't go into this. From this view, which is a rather online view, you can see this is an online demo. So you can go through your data. You can see the changes in the date. So you have time navigation on top. You can go through this rather quickly, even using your keys page up, page down to go through time. However, this is probably not the best view for people who want to really analyze stuff. So we can go in our plot view to have more screen real estate. This gives you this beautiful visualization. Afterwards, you could, for example, have the idea to see some specific date time. So you can pin some profiles in time from this view. And then once you pass over to the next view, you can see that you can find out what the changes in time are. However, it has been discussed. What we see here is actually the absolute deviations. What we most of the time are interested in is a relative time view against some kind of a reference date. So if we were to go to the same view at a specific time, we can actually set this date as a reference date. And at that time, it pulls everything to 0, and all further measurements have been calculated and are relative against that time. You can see the reference time here. So the reference time is the 11th February 2020. That's a nice feature, but you probably also are interested in what your data looks like through time. You could actually select a vertex here, which is actually on 52 meters depth, plot this through time and see what the evolution through time was. You can actually also see that it's been pulled to 0. From this view, we can also select where we want to have our profiles plotted. So you can pin some profiles at the beginning of your measurement, during the change, like this. I won't make too much of an effort here, but just to give you an idea. And then once you know where you have your points plotted, you can plot them in the z-axis. And on the top, you see all data points that have been selected. Another thing that we see on this view is you have this green line. People who have really looked at the graph from afar already know this. What is this actually? This is actually the visualization of the surface. So how can you set this? Well, actually you can go inside the system. You've got two fields there where you have the elevation, which is the top of the borehole, or the top of the inclinometer tube, and the surface, which is then actually ground level. And at that time, your ground level will be projected on top of some of the actual graphs. What's also in here, because we have this this elevation and this surface definition, is that we can actually calibrate your data to meters above sea level, and that gives you the option to actually see multiple instruments on the same level. So you can have multiple inclinometers from different boreholes or different places on the same view, just to have a contextual view of multiple inclinometers at the same time. One of the views that is probably also known is where you have multiple vertices through time. You can do this in this fashion, and just by selecting multiple fields here, we will see that you will get some overview of all the different vertices through time and their evolution. That is just about what we do for normal operation and normal evaluation of data. What we also see, and as Giorgio also said in his talk previously, is that sometimes things can go a bit wrong. So I'll just change this here a little bit, go a little bit up. For example, should you have a problem in your inclinometer tube where you have some kind of, it's filled with debris in the bottom, that means that your inclinometer probe will not go to the bottom anymore, which is quite a problem because you lose some information, or you possibly lose the borehole for using. What the system here can actually do is, and I will show you, because these are not a lot of data points going through the data in time. You can see that at this time, the debris has actually fallen inside the hole. We can, however, recalculate what has happened at the time just by pinning it over here and changing it. You can see that we can, once it's been filled up, we still have the same data set, but then from a from a higher point, actually where we have the 0 point, we can recalculate the slope from where the borehole has been filled. And then lastly, because we're very happy to see that that is actually a useful feature. We have the review section in which we give you an overview of all your latest inclinometers that have been measured. And Giorgio talked very eloquently on the use of checksum data. This is actually what we present here. So you have the calculation of the checksums. These are the last 10 and the first 2 checksum measurements that have been done, both in the A direction and in the B direction. This is just to spot where probably some errors could have been or could be present. And on the right side, we have the displacement map in which your first measurement is used as a reference, or so has been set as the reference for that inclinometer, and then the last 2 measurements to see whether there are big displacements in that whole section. We can definitely also provide people with the possibility to add reports. How you do this is rather easy inside the system. Once you select which inclinometer you wish to have a report on, you select multiple inclinometers. Here, you create some kind of just a standard report. You can print this out, and it generates a rather nice template file, should it want to display, where you have an overview of where your inclinometers are have been created and where the report has been done. This report can also be saved, and at that time it will provide you with the option to do this at regular time frames. One last thing that is possible inside the system is that we can create in some sort of a formula fashion, is that we can create virtual sensors. This is our current solution for recalculating and to do vectorial combinations so that you can actually do the rotation of the inclinometer, and even take into account possibly should there be any torsion of your inclinometer tube, and you know the amount of torsion, you could manually add these formulas to the system and have some changes to your or recalculated data based on what was actually measured. This is just about it. This is what we do inside the system. Should you want to take out information out of our system, then we have a number of possibilities. We can do this in an automated fashion, but we can also do it in this kind of programmatorial way in which programmers can get data from out of the system in a rather easy fashion. That is about it, Giorgio, for us.